Hi everyone, this is Mrs. Mitchell, and today we're beginning a new unit on parallel and perpendicular lines. The very first section, 2.1, is on parallel lines. So what are two lines? Well, you probably think about parallel lines as two lines that don't intersect, but more specifically, they're actually coplanar lines that do not intersect, because there's something called a skew line, which are two lines on two different planes. They're never going to intersect. So think about that for a second. So if you have a plane like this, right, and we have a line on the plane, but we have another line that's going through the plane or through the paper, if you will, right? You go through it, right? Go through it here. It's never going to intersect the line that's actually on the plane, okay? So those are considered skew. But parallel lines are coplanar lines that do not intersect. They're on the same plane and they don't intersect. And this notation here, that's the notation for parallel. Parallel are used to indicate that lines are parallel. So in this picture here, we could say that line AB is parallel to line CD, right? And then we have parallel planes. And very simply, planes that do not intersect are parallel planes. And usually one of two things can happen. You could have one letter on a plane, not a point on a plane, just a letter. And we could refer to this as plane J and plane K. But we could have at least three letters on a plane that are not collinear. So let's say ABC, and then we could call that plane ABC, ABC plane. Okay, but in this case, we have plane J and plane K, and they are parallel. And then we talked already about skew lines, and skew lines are non-coplanar lines that do not intersect. So if we look at this picture, this box, if you will, we can say that TU, line segment TU, the top of the box, one of the lines on the top of the box, and WS are skew. Okay, so you can see, like, if you take this little, let me get a different color here. So if we look at TU, right, and we look at WS right here. Now it looks like it intersects, but it doesn't, right? Because think of the box, right? The TU is on the outside and the WS is back further, right? So, and those, they are not going to, they're not going to intersect, but they're not on the same plane. There's no way to connect those 4 points and make a plane. PQ, let me get rid of my red. I think it's making it look, I think it looks worse. Okay, so PQ and VR. PQ and VR, never going to intersect. And they are not on the same plane, so they're skew. And TP and SR, again, never going to intersect, not on the same plane. There's no way you could connect TP and SR and make a plane. So it's not coplanar. And again, just because you don't see the plane doesn't mean it's not coplanar. Okay, the point is, if you have any three non-collinear points, you can create a plane with those points. Okay, but with 4 points, it doesn't always create a plane. And the point is, you could never connect those 4 points. Okay, what I would like you to do is try to shut off the video for a few minutes and try to do this page, okay? And then come right back to it and see if you have the correct answers. So stop it and come back. Okay, so you're back again. Name all the segments parallel to AE. All right, so here's line segment AE right here. All right, and you know what? Let's just erase this because I feel like that makes it harder. All right, so segments parallel to AE, so we have HD is parallel to AE because we can connect those 4 points and it really does make a plane. FB and AE, right? That you can see it's the side of the box. That makes a plane. GC and AE. Now that's not a side of the box, but you could take, let's say, a piece of cardboard, right? And you could connect EA to GC. And that would make a plane. All right, give 2 examples of parallel planes. So we have plane AEF. Now you may have called it EAB, all right? But you have to pick 3 letters on that plane. All right, so plane AEF AEF, so this side of the box here, and plane HGC. They are parallel. Okay, they are parallel planes. They're never going to intersect. And plane HED, the left side of the box, is parallel to the right side of the box, which is plane BCG. Name all the segments that are skew to segment GH. All right, so GH is this top line on the top of the box. It is skewed to FB. It will never touch FB. It is skewed to EA. Again, it will never touch it. DA, it will never touch it. And BC, it will never intersect HG. Okay, I'm going to let you review the answers down here and make sure that they are in agreement with what you did on your own. Okay, let's go to the next slide. Okay, so the focus of today's lesson is on the different kind of angles that are formed by transversals. So first of all, we have to talk about what a transversal is. And a transversal is simply a line that intersects two or more lines. So in this picture up at the top, we have line L and we have line M. And the transversal is the line that is going through those two lines. And the angles that are created with the transversal and these lines has names. So one is called corresponding angles. So angles on the same side of the transversal and in the same position. All right, so if we look here to find corresponding angles, right, we could see that 1 and 5, so this here, 1 and 5 are corresponding because they're both on the left side of the transversal and they're above the lines. All right, 2 and 6, let me take a different color. All right, 2 and 6, the same situation, right? They're both above L and M, respectively, right? And they're on the right side of the transversal. Their position corresponds. All right, angle 3 and angle 7. 3 and 7. I don't like what I'm doing there. Let's see. 3 and 7. Let's try again. Okay, there we go. Let's go with 3 and 7. All right, they're both below the line, L and M. All right, and they're on the right side of the of the transversal. So they correspond. And lastly, 4 and 8. All right, so 4 and 8, here's 4 and here's 8. They're both below the lines L and M, and they're to the left side of the transversal. So these angles correspond, 1 and 5, 3 and 7, 2 and 6, 4 and 8. All right, let's look at alternate interior angles. Okay, alternate interior angles are interior angles, so they're on the inside here. They're non-adjacent, okay? They're not like right next to each other, okay? And they're on opposite sides of the transversal, okay? So if we look at 4 and 6, okay, 4 and 6, they are alternate interior angles. They're on alternate sides of the transversal, and they're inside the lines L and M. And then there's 3 and 5, okay, 3 and 5. Again, they're on alternate sides of the transversal, and they're on the interior, okay? And then there's the same thing, only on the exterior, alternate exterior angles, right? So we have 2 and 8, right? 2 and 8, they're on alternate sides of the transversal, and they're both on the exterior of the lines. And then there is 1 and 7, okay, 1 and 7, and again, they are on alternate sides of the transversal, but they're on the exterior. And now there's something called, this paper that you see here calls it the consecutive interior angles, but our book is going to call them same side interior angles, and I like that anyway. I think it's clearer. But same side, and they're on the interior. So 3 and 6 are on the same side of the transversal, and they're on the interior. Those are same side interior angles or consecutive interior angles. And then 4 and 5, same thing. 4 and 5 are are on the same side of the transversal, okay, and they are on the interior. Okay, you can on your own, you can do this next page, check it, and make sure that you're getting the exact same answers that I have here. So you can stop the video and check it, and if you have any questions on that, just bring them to class with you. Okay, again, this next page, give this one a try too, and then I'm going to discuss each one of them, but give it a try before you really look at the answers here. Okay, if two lines are not perpendicular, then they are sometimes, always, never coplanar. Well, they could be skew, right? If they're not perpendicular, let me just think about it. If they're not perpendicular, right? So you could have parallel lines, and parallel lines could be perpendicular. You could have intersecting lines that are not perpendicular, but they still would be coplanar. But the situation is you could have skew lines, right, that are not perpendicular, and they would not be on the same plane. So for that reason, the answer would be sometimes. Skew is always the tricky one, all right? Often got to think about skew because that's not always the situation that comes in one's head. If two lines are coplanar, if two lines are on the same plane, then they can never be skew, okay? So the thing is, like, you might think of a picture, right, where I have a line going through this plane. Okay, I have a line going through this plane. All right, and then I have another line going through this plane. So in the diagram, right, it looks like they're not on the plane that I have drawn. However, I can draw a plane connecting those two lines. All right, so, but if two lines are on the same plane, they cannot be skew. If three lines are coplanar and they never intersect, okay, so they're on the same plane, and they never intersect, they have to be parallel. All right, and if two planes are parallel, well, then the planes are never going to intersect. So the big one you really have to think about is skew. That's the tricky one. Okay, this is 6. Okay, so 6, the same thing. I'm going to have you just practice this, do it, and then just check your answers against my answers, and again, come to class with questions you might have. Okay, so we have 4 theorems that we're going to talk about today. Actually, 3 theorems and a postulate. All right, and the first postulate is the consecutive interior angle postulate. Okay, or really what we call it is the same side interior angle postulate. Okay, and what does a postulate means? It means we can't prove it, all right? So we have to assume that that is true. Okay, and what we're saying with the same side interior angle postulate is that the same side interior angles have to be supplementary. We're going to go through this in a second, but angle 4 and angle 5 has to be supplementary. Now, this is if two lines are parallel. All right, that's the big if. If two lines are parallel. In the pictures that came before this, the two lines were not parallel. All right, so you can have corresponding angles, alternate exterior angles, alternate interior, and same side interior, but they're only congruent or supplementary, depending on the theorem, if the two lines are parallel. All right, that the transversal is going through. All right, so in this case, two parallel lines. Angle 1 is congruent to angle 2 by the corresponding angle theorem. Angle 1 is congruent to angle 3 by the alternate exterior angle theorem. And angle 2 is congruent to angle 4 by the alternate interior angle theorem. Let's look at each one of these more carefully. Okay, so the same side interior angle postulate says, again, if a transversal intersects two parallel lines, then same side interior angles are supplementary. So this line is parallel to this line, okay, and this is the transversal. So what we're saying is that the same side interior angles are supplementary. So the measure of this angle plus the measure of this equals 180, and the same thing here. The same. So this angle here. Why don't I mark it in blue, because it's going to turn out to be the same as that one. And this angle here will also add up to 180. So this is going to be 120, and this is going to be 60. So the postulate says that same side interior angles are supplementary. Can't prove it, it's the postulate. All right. The next theorem, or the first theorem we're going to prove in this section, is the alternate interior angles theorem. Right. The alternate interior angles theorem, given m is parallel to n, and we want to prove that angle 1 is congruent to angle 2. So, all right, so we rewrite the given, and we know we know that angle 1 and angle 3 are supplementary. Okay, and that is true because of the consecutive interior angle postulate. Let's just call it same side interior. Same side interior angle postulate. All right, so if angle 1 and angle 3 are supplementary, then the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees. And that's because of the definition of supplementary. Now, we also know that the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees because of the linear pair theorem. All right, we have a linear pair here. And now because step 3 and step 4, they're both equal to 180, we can say that the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 2 plus the measure of angle 3. And that is the substitution property of equality. And then we can subtract angle 3 from both sides, and we get measure of angle 1 equals measure of angle 2, which is the subtraction property of equality. And then, of course, we can say that angle 1 is congruent to angle 2 because of the definition of congruent. So that's the proof of the alternate interior angle theorem. Now let's prove the corresponding angle theorem. Okay, so we're given that m is parallel to n, and we've marked the parallel mark. And we want to prove that angle 1 is congruent to angle 2. So we have a statement column, and we have a reason column. And so step 1 is just restating the given, which is m parallel to n is given. Okay, now we can use the theorems or the postulates that we've already talked about or proven to prove this theorem. So I'm going to use the same side interior angle postulate. I'm going to say that angle 2 and angle 3 are supplementary. And the reason for that is the same side interior angle postulate. Okay, so, and now if angle 2 and angle 3 are supplementary, I can say that the measure of angle 2 plus the measure of angle 3 is equal to 180 because of the definition of supplementary. All right, I can also say that angle 1 and angle 3 are a linear pair. All right, and when you can just see it like that, you can say that's because of the definition of a linear pair. So that's the definition of a linear pair, and then we can use the linear pair theorem to say that the measure of angle 1 plus the measure of angle 3 is equal to 180, and that is the linear pair my goodness, was that a postulate or a theorem? The linear pair theorem. Linear pair theorem. Okay. So now we have measure of 2 plus 3 is 180 and 1 plus 3 is 180. So we can use transitive property, right? And we can say that the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 2 plus the measure of angle 3, which is transitive property of equality. Okay, and then we can subtract out 3, and we can say that the measure of angle 1 is equal to the measure of angle 2. Subtraction, property of equality. And then angle 1 is congruent to angle 2, which is the definition of congruent.